Okay, here we go. 5, 6. We're going to talk about indirect proof and inequalities in two triangles. The great thing about this section is we already talked about inequalities in triangles. We did that yesterday. So today totally builds off of yesterday. Other than this brand new thing right here. Guys, underline it. It's kind of weird, but I'll show you what that is. And then will you circle this? Hinge theorem. Guys, just make a crocodile sign with one hand. It's kind of like a hinge, right? Just one stays, one moves. We'll talk about it. The great thing about this is draw a little arrow. It looks very similar to side angle side, so we can tie in last chapter. And then we'll use stuff off of yesterday. Okay, let's start with indirect proof. Now I'm going to show you something, but I don't want you to copy it down. Are you ready? It'll take way too long to copy it down, and it's kind of wordy. So indirect proof, if you look later on in your notes, there's a typed up version of the steps, and I think they're a little bit easier to follow. So jump to the next page in your notes. It's at the top of page 113. Skip that. So again, this is top of page 113 in your notes. I think this is a little more clear, a little easier to understand. If you watch the YouTube video tonight, you can always pause it on that first one and get it down if you want to, but I think this makes more sense. So what you want to do first, if you're making an indirect proof, the first thing you have to do is identify the statement you want to prove is true. So keyword in this one, I'm going to highlight it. Identify. Okay, so a ridiculous example, let's say you want to prove the misstatement is short. All right, here we go. So we're proving the misstatement is short. What you do with an indirect proof is you first identify, so we're going to prove the misstatement is short. That's what identifying is wanting to prove true. Now you prove the opposite. So we want to prove the misstatement is short, so you're going to say the statement is tall. So you start with the opposite and you prove that. What's going to happen is you'll contradict yourself. So right here, then you go to the false version of that. Just like a regular proof, you go through your statements, you go through your reasons, and then this is what's going to happen. You'll get a contradiction. It won't work. Okay, so ridiculous proof. Prove misstatement is short. So we're going to start with misstatement is tall. So you bring in someone who's tall, you just contradicted it, right? Misstatement is not tall compared to a tall person. Okay. All right, let's do this right now. I'm going to show you all one by one. Okay, indirect proof. We're going to fill in the blanks. Now I know it's so tempting to just fill in the blanks, so now stay with us. Here we go. You know what, I'm actually going to zoom. Here what are we trying to do? Prove that a right triangle cannot have an obtuse angle. How many are like, yeah, I already know that. Not possible to have an obtuse angle in there, right? Okay, so I'm going to use this example to show you indirect proof. So we're going to show ABC is a right triangle. The 90-degree angle is right here, angle B. We're going to prove it doesn't have an obtuse angle. Stop. The first thing you do on indirect proofs is you identify what's true. So triangle ABC does not have an obtuse angle. Thumbs up, that's true, right? So the first step in an indirect proof, you make that false. So right here, the very first step is, let's say it does have an obtuse angle. We're going to start with the backwards version, the opposite version. Again, that's the first step. That's what your homework assignment is going to be tonight. It doesn't ask for the whole proof, it just asks for the first step. It's kind of like 2 in 1. First, identify what's true, and then make it false. Okay, so here we go. So this is our first false thing. Let's say measure of angle A has to be bigger than 90 degrees. Bigger than 90 degrees. Do you agree that that's obtuse? Yes. Okay, so we're going to say angle A is the obtuse angle. All right, well then in a triangle, measure of angle A plus measure of angle B, they'll have to be bigger than 180. We add our angle measures together. Right? Okay, but then any 3 angles in any triangle always have to equal what? Okay, so that's our next. We're just going logically one by one. What do we know about triangles? So all angles always add up to 180. So super low on the board, A plus B plus C angles has to be 180. You with us so far? Okay. We're going to slide it up. You ready? Here we go. What they do here, don't get this. They're just, how would you get rid of a plus measure of angle C? Yep. So they just subtracted the measure of angle C right here, subtracted it right here, and just rewrote it right here. Do you see that? is the exact same thing, only they moved measure angle C to the other side. Okay, maybe this is too big. Let me move it down a little bit, see if you can see what came from. Take this, minus the measure of angle C, and substitute it for measure angle A plus measure angle B. So it's kind of like they're combining these two. And they're rewriting it right here. Okay, so they took out this, and they put 180 minus measure angle C. That's going to have to be bigger than angle 180. Okay. So right here, I guess it's better if we take out this, and that's what they replace. Did I lose you on that one? So again, rewrite this. They took out measure angle A plus measure angle B, and they put in this. So now we have this. Okay, think your algebra skills. Guys, how would you get rid of a minus measure angle C? Okay, I'm going to add some steps in here so it becomes a positive. Okay, so rewritten over here, we would have 180 is bigger than 180 plus the measure of angle C. Okay, what would you do with the 180s? Well, what happens? Right here. That's where this came from. Subtract 180 from both sides. So 0 is bigger than the measure of angle C? What's the problem with that statement?
You can't.
Tyler, thanks for raising your hand.
Can't be like less than 1.
Nope. Perfect. Perfect. There's your contradiction. So right there, right, here's our contradiction. Our angle cannot be less than 0. Oh, I put contraction. Oh my goodness. Okay, there's the problem. So when you hit your problem, there you go. Let's move it up. They can't be negative, so we can include that the assumption is false. Therefore, the opposite has to be true. Holding in. Seems like such an easy thing to assume, right? Okay, will you put your head down, cover your eyes real quick? I have some clarifying questions. How many of you, the idea of indirect proof makes sense to me? I understand where it comes from. The starting with something true and then saying it's false. Okay, hands down. How many of you, that proof, I pretty much followed it? Awesome, hands down. How many of you, I was just copying? I did not understand. Okay, sweet, guys, thank you so much. All right, heads up. That's it for indirect proof. Again, don't be intimidated by that. That's like one teeny tiny piece of this entire section. The emphasis of this section is the hinge here. So one more time, I know I've said it before. Indirect proofs. First thing you want to do is identify what's true. Nod your heads. Got it. Identify what's true. The second step. Do you remember what the second step is? Yes. Make it false. That's it. That's what I want you to remember. Identify what's true. Second step. Assume it's false. Do the opposite. Okay. Let's go back and this one. The hinge theorem, and I really think you'll pick it up quick. Let's just worry about, well, you always copy stuff down. So copy it first, and then let's look at the pictures. Okay, remember last chapter how we did side, angle, side, and angle had to be in the middle? Don't you think that this kind of looks like side, angle, side? Only what's the problem? The angles aren't the same. So we can't say side, angle, side because the angles aren't the same, but the angles still sandwich in between, and that makes a difference. So right here, across from the 100 would be the biggest side. Do you remember doing that yesterday? So this side, across from the WX, that might be the biggest side. But what we're doing is we're comparing this side to this side. Which one do you think has to be bigger? RT. That's it. Across from the bigger angle is always the bigger side, so it's the same thing as yesterday. Even though we have different angle measurements, you can still decide which one is bigger. If 100 is bigger than 80, then that side has to be bigger than the other one. Question, Alice?
Sides that don't have to be congruent.
Yes, that's a big deal. So Allie's question, but you have to know. Yes, yes, yes. This side is the same as this side, and this side is the same as this side. So kind of like side and side. Other than the angles, that's where you go from. And then the converse is true. Go opposite of it. So if you know that this is 8, and this is 7, and you know this side is the same as this side is the same as this side, which one is bigger, 8 or 7?
8.
So which angle has to be bigger?
8.
There you go. A has to be bigger. How many? I got that. help you guys start off with that. Okay, let's jump. So flip a page. Okay, in your notes I highlight this because I was making a copy of the notes for the absent kids and I totally missed this. So it's actually a multiple choice question. It's saying which of the following is a possible length out of 16, 19, or 22? I totally missed that. So here we go. Right here, look at your angles first. We've got a side and a side, side and a side, angle and angle. Which one is bigger, 50 or 42? 50 is the biggest one, right? So right by that 19, let me change the font a little bit. Right by the 19, just write biggest. Because that angle is the biggest. So 19 has to be the biggest. Across from the 42 has to be smaller than 19. So which one of these options works? There you go, that's it. 16 is the only one that would work for that, out of our three choices. Does that make sense? Okay. Alright, letter B. Same thing. We've got side, angle, side, side, angle, side. This one's 20. That's 3.7. Look at your sides. Which one is bigger, 4.3 or 3.7? So right here, that's the bigger one. So this has to be a bigger angle. Alright, bigger than what? Has to be bigger than 20. Guys, out of those options, which one is bigger? 25. Circle it. Good. Alright, will you vote with your thumbs up, hands sideways? Just these two examples, how you feeling about them? Let me see, all thumbs, all thumbs. Okay. What about these ones? Again, look at your angles first. Make a choice. Which one is bigger, 50 or 53? 53 is bigger, so this has to be bigger too. So write an inequality in there. It wants to eat the YZ inequality this way. How many got that before you down the board? You good? Okay, move to this one. This one, even though it's overlapping, they're sharing a side. Across from angle 2 is 13. Across from angle 1 is 14. Guys, which is bigger, 13 or 14? Okay, so this has to be the bigger one, right? So which angle has to be bigger? There you go. Yeah? Are we already done with the chapter? Okay, let's get your worksheet so you can work.